Hello everybody, I'm Nikki Thomas. I'm a teaching learning coach for Ogden Trust, and this is the first tutorial for the Matter and Space Skipped module. So in this tutorial, we will look at calculations and equations, thinking about how we make them relevant, looking at conversions, how we bring out that physics that can be the difference between treating it as a maths question and a question in physics. So how do we introduce numbers in physics? Just pause and think, how might you introduce calculation? So I would say that there are three stages. Starting off by being descriptive. I've got a bottle of Coke, a bigger volume of Coke has a bigger mass. Just looking for a simple pattern. And that can be enough to calm down somebody who's having a little bit of a panic about the fact you put some numbers in front of them. How about qualitative? Well, if I have 2 bottles of Coke, then I'll have double the mass. And if I want to calculate something that's quantitative, imagine that 500 ml of this Coke, well, it does, 500 ml of the original Coke, have I got the right one? Yeah, that one. That had a mass of about 509 grams. So the mass of 250 ml, half of it, would be half of that. So the main idea I really want people to focus on is that equations really are more than just letters. So you're using those words and symbols, but you're telling a story. So you want to think what you're working out. Where do you get the values? Are they from an experiment? Are they from a question stem? Is there other information you need? Choose the equation and think about the units you're going to use. And then sort of think about the skills that perhaps are a bit more to do with maths, actually doing that calculation once you put those numbers in, changing the subject or rearranging the equation. On the whole, we find maths teachers seem to be more likely to use a phrase, changing the subject, which students are a bit more familiar with. Think about those powers of 10 and avoiding calculator errors. So these questions here, how long does a kettle take to boil? Why does fruit and veg float? How much sugar does a fizzy drink contain? They're all physics questions that can be answered by using calculation. And we can sort of gently build our students up to actually quite enjoy doing these, I would say. So imagine I have my bottle of Coke. I've got Coke Diet Coke, I've got Coke Classic. I'm sorry, I've got a blurry background on, so these don't look like normal bottles, but honestly they are. So if you're trying to think, for example, they're identical bottles, they've got an identical volume of liquid. How would I work out the density? The difference between these two drinks is really just the amount of sugar that's been added. Okay, we put a sweetener in. So roughly how much added sugar is there? How would you calculate that? So what I'd like you to do is think of those questions and think how you would calculate that. We'll move on to the next slide and just look at it in a bit more detail. By all means, pause this if you're having a think. So when you're wanting to work something out, you need to think, what information do you need? If I want to know the density, what information do I need? What am I going to measure? What do I do with the information? So you think about the equation for density, mass over volume. So I need to know the mass, I need to know the volume. What can I actually measure? I can't measure density direct, but I can measure mass, I can measure volume, and then do the calculation, for example. So if I am looking at the density, I'd measure the mass of an empty bottle. It's about 25 grams, maybe drop that down, 25 grams. The classic Coke bottle, the mass of that, so the liquid plus the bottle, is 509 grams. So you can work out the mass of the liquid. The Diet Coke, the mass of the Diet Coke liquid plus bottle is 496 grams. So again, you can work out the mass of just the liquid, and then divide each of those by 500 ml, because it says on each one of these You maybe can't see it, but it does say on here that these are 500 milliliter bottles, okay? And a milliliter is a centimeter cubed. Just a quick reminder again. And so you can find the density. And remember, the density will be given in grams per centimeter cubed or grams per milliliter. And if you wanted to find how much added sugar there was, well, you're taking the difference between the bottle of Coke, sort of full fat Coke, the sort of the original, and the Diet Coke. And that's about 13 grams of sugar that's been added to 500 ml of Coke additional. And if you work it out as a percentage, well, sort of percentage, or per how much is there per milliliter, then you divide by 500 milliliter, and it's quite a bit. It's about 3 teaspoons, isn't it? I think a teaspoon's about 5 grams of sugar. Okay, units, they're not optional. Please don't let your students sort of ignore them or vaguely put them at the end. You've got to be aware of these units all the way through. And think about converting those units as a separate step before you do the calculation. It's a lot harder to try and do a conversion after you've done a slightly complex calculation. So personally, I would definitely try and do it first. Do we actually need to do a conversion? Quite often, if you've been given information in milliliters and centimeters cubed, you can give your answer in milliliters or centimeters cubed or whatever. If it's been given in kilograms and meters cubed, then leave it like that. So try to avoid an unnecessary conversion. I would break any compound conversions into steps and provide lots of practice. So you may well give your students a chance to practice some of these conversions, just separate as a plenary, as a starter, as a homework, just maybe every week or so, just a couple of questions they do in each lesson just at the beginning. So look at this question here. How would you calculate the area of a sheet of A4 paper, your standard A4 paper? You're given the measurements in millimeters. A millimeter, the milli means a thousandth, is a thousandth of a meter. Okay, so how would you do that? Pause, and we will go on and talk through the calculation. But you want to give the answer in centimeters squared and meters squared. So you want to know the area. You know the measurements in millimeters. You want the answer in centimeters squared, meters squared. So what would you do? To convert millimeters into centimeters, divide by 10. So we've got 29.7 centimeters and 21 centimeters, and then multiply together. And I get an answer of 623.7 centimeters squared. This is where your students probably wouldn't lose a mark if they put the 4 numbers in, unless they were being asked about significant figures. So if you look at the top, we've got 297, it's 3 significant figures, and then the 210, we can assume, I think it's okay to assume that's 3 significant figures. So my answer should be 3 significant figures. In other words, instead of 623.7, we should put in 624 centimeters squared. And sometimes students get confused. Do you make, is the number going to be bigger or smaller? Just remember, you will have less centimeters. If I've got my sort of, 15 centimeter ruler, I've got 150 millimeters. So I've got to divide to get my centimeters. And if we're doing our calculation in meters squared, instead of dividing by 10, we divide by 1,000. And the answer is 0.624. Okay, 0.624 meters squared. How might you get a student to look at this calculation? If you've got the density of an apple, which is 100 grams, and a volume of 110 centimeters cubed, express your answer in kilograms and meters cubed. I would suggest it is simpler to change 100 grams to 0.1 kilograms. There are 1,000 grams in kilograms, so 0.1 kilograms. and the volume 110 centimeters cubed, that is going to be a much smaller number. That's going to be divide that by 1,000,000. So you're dividing the top half by 1,000 and dividing the bottom half by 1,000,000, because what we have 1 centimeter is 100th of a meter. 1 centimeter squared is 1 over 100 times 1 over 100. So 1 centimeter cubed is 1 over 100 times 1 over 100 times 1 over 100, which is 1 over 1,000,000. Okay, and the answer you should get is 910 kilograms per meter cubed. And there's a little bit of a hint as to whether you might be absolutely ridiculously out with your answer. They've given you the density of water is 1,000 kilograms per meter cubed. So the apple has a density of 910 kilograms per meter cubed. If your conversion had gone a bit weird and you had an answer that was 0.0019 or 9 or something compared to 1,000, it's kind of like, that doesn't quite make sense. So we've got our answer of 910 kilograms per meter cubed for our apple, which is less dense than the density of water, which is 1,000 kilograms per meter cubed. So this is just talking through what I've just said. I hadn't quite remembered this slide was here, but it hopefully helps you make sense of what I just said. How about this question? This time there are 2 steps in this. You've got 4,000 meters cubed of helium. You're told the density of helium in kilograms per meter cubed and being asked for the weight of the helium. So first of all, we're not being asked for the density. We will have to rearrange the equation. And can I quickly point out that if you are in an exam situation, substituting first, so writing out the equation, density is mass over volume. If you substitute the numbers from the question first, correctly, you will get the mark for that, even if your students then rearrange the equation incorrectly. So strongly recommend that you do substitute first. So the density is mass over volume, so 0.17 is the density, equals the mass divided by 4,000 meters cubed. If we change the subject to mass, then we get 4,000 multiplied by 0.17 is the mass, and the answer for that is 680 kilograms. Read the question carefully. Can you spot why I haven't quite finished? Okay. Hopefully you spotted that we asked for its weight, and weight is mass times gravitational field strength. And I did a little poke around in some of the data sheets. At GCSE, they will normally they will tell you what the acceleration or the gravitational field strength on Earth is. It's they usually will give 9.8 newtons per kilogram. So I have to multiply 680 by 9.8, giving an answer of 6,664. The only thing, and here's this on this stage, sorry, there we go, talking about it. The only thing I would say is that is given to 4 significant figures, and you might need to, if the question asks you to do the correct significant figures, on the previous slide, you could see that I had 2 significant figures with the density of the helium, 0.17. It didn't say 0.170, it said 0.17. So that's 2 significant figures. Okay. So the next little bit here is really getting you to think about something called Isaac physics. And spend some time yourselves independently on this website. So what I'm going to do is I'm going to suggest you go to, you might want to take a little screenshot of this, but I'm going to show you how to get to these slides. In fact, I'll put them in any email I send with the links. I would suggest you only look at the density questions. We haven't talked about the gas board, gas questions, gas laws questions. If you feel inspired, you are very welcome to go and explore Isaac Physics. But at this point, I will only ask you to look at the density. So it's a free website. It's packed with interactive questions. And the kids can just do those questions, get immediate feedback. If you've created a group for your class, then you actually also get the feedback as to how well they've done. So I'm going to stop sharing now for a moment. I hope. Excellent. Fine. Okay. And now I am going to share my screen, I hope, to show Isaac Physics for you, and you will be able to just see what we're doing. So what do I want to do? I want to go to window. I want to go to... Okay. So this is the Isaac Physics website. And if you just Google Isaac Physics or isaacphysics.org, in you go. And I will also tell you that if ever you get lost on the website, just look for this hexagon in the top left-hand corner and you come back to this screen. And we're going to look at some of the quizzes. So I go to they've arranged them by age, so 11 to 14-year-olds, step up to GCSEs, that's suitable for year 9. We've got some questions which have come out of a textbook book, which are nice and sort of routine questions. Let me look at this. So we've got here, you can see what I've got is I've got questions linked to materials and forces, and you can see there's a question on density, view board, and there's also density quick view board. Let's look at the quick one. If I click on view board, get some straightforward questions. I'm going to click on that question. 500 centimeters cubed of olive oil has a mass of 450 grams, calculates density. So we've got, remember density is massive, volumes I've got 450 divided by 500, which gives me an answer of 0.9. So I'm going to type that in. And I've got units here, and it's grams. So you've got grams in the question, and you've got centimeters cubed. So I'm going to choose that one, check my answer. Hooray, it's correct. What if I had put 0.8? Check my answer. It's incorrect, and it's told you to check your working. Perhaps if I put 0.9999, and then just lots and lots and lots of zeros, check my answer, and it said whether it's correct or not, it's got too many significant figures, which is quite nice to sort of remind our students what they're supposed to be doing. And if I put the wrong units in, it tells me check your units. And underneath we have hints with some notes on density, and we also have hint 2, which is telling you to find what you're aiming to do and what information you have. So just helping our students structure their answers. So you will be going away when you get this recording in the email with the link. You will also have the links to these places, these questions. So you will be able to go away and explore yourself. Let me just stop sharing. There we go. So thank you for joining me. Please, when you've watched this, can you drop me a line, nikki.thomas@ogdentrust.com. Again, you'll have the link in the email, and I will ask this in the email. Please, will you drop me a line and say you have watched this so we can tick this off as attending the first tutorial. The second thing is just to quickly remind you, keep logging on to Open Learn Create. And make sure it is Open Learn Create, or else you might, if you go to Open Learn, it is a different site. So Open Learn Create. We're expecting to do quizzes for weeks 2 through to 7, so 6 sets of quizzes, and then a professional reflection. I'm sure your tutors will remind you, but it is just a little kind of reminder as well. Thank you very much.